Hello there. This is my first YouTube live. Hope you are well. And Ishak Guse sent me a request to solve his problem. That's why I came up live to solve this problem. You can also send me request by my WhatsApp chatting, also in my YouTube comment section. So here today I'll discuss about IDW technique. So first of all, this one add data you all know in ArcMap. This is a common function, and Ishak Guzza has sent his boundary shapefile. This one boundary shapefile. Add it. So this is the boundary, and he also sent me data. This one IMD station data, and also this one station information, and also this one annual data, annual temperature, rainfall, temperature, minimum temperature, maximum temperature, and precipitation from 1980 to 2019, and for 6 station. So IDW is very easy technique, you all know, but sometimes we may face some problem when we adding Excel with ArcGIS. So today I'll solve this problem, and you never face similar kind problem to adding Excel in ArcMap, also in interpolation technique like IDW. So first of all, here see one thing. In this case, boundary. Right click here. Go to this properties first, because we have to check the source file. So go to properties and then go to source here. Now see this one, WGS 1984 ETN zone 43. So this is the main error why you face problem, because when you add this shapefile, you should add it in WGS format, non-UTM format. So you should convert it in WGS format. So you can convert or you can reproject in many way. Like one of the technique is right click, data frame properties, and then you should select WGS 1984, apply and OK. And another technique you can do in Arc Toolbox. Just click on Arc Toolbox, then data management tool, this one from your Arc Toolbox, data management tool. Okay, and then you can find project and transformation, this one, project and transformation. Okay, so you have to click this project and transformation here. Just click on this plus sign, then project it, because this is a vector data. That's why you have to click here. Now project it. How to project it? Here the input database or feature class. So in this case, it's boundary. You can drag and drop. Okay. Now see, input coordinate system UTM zone 43, and output coordinate system. Just click it here. And you can select WGS 1984 or CGS WGS 1984. Both are similar. Just click it OK, and you have to change your output path like this one. Just click it, this symbol, this folder symbol, double click here, then you can change it. Like I want to change it, save it here. This is for Ishak from Senegal. He is a research scholar. Okay, this is, see this one, same name with 2 folders. This is a common problem in ArcGIS. So just up one level, then again go this folder, this D drive, and now see 1. So just double click here, name it, suppose, okay, so with same name, boundary, and save it. Okay, you can give here .shsp. The SSP is a file format. So now click it OK. Okay, now these are projected, that's when in geographic projected data, this boundary. So we have to do now one thing, we have to manage our data. So here Tmax, that's mean maximum temperature from 1980 to 2019. First of all, we have to calculate here average. So average type here is equal to average, then bracket, then select first cell, this one C6, C4, okay, and then series bar, give H2 symbol, then suppose C52, no, 43, up to 43, so just 43, type here 43, and close this bracket again and press enter. Okay, now click it, just drag it. Okay, now just take a copy and Ctrl V. Now see, just take a copy and Ctrl V. If you click here, then you can find it is average of this cell. It is average of this cell. Okay, so now again take a copy, paste here, paste as a value. Now this one, paste as a value, only we need value. Here the information about our stations, just take a copy again and paste here. So this is for maximum temperature. Okay, we can arrange it like this way, just take a copy and paste here, paste as transpose. Okay, so this one for Tmax. Okay, again similar way, take a copy and paste as transpose, this one for Tmin. Then again take a copy, you can use shortcut Ctrl C and transpose this one precipitation. Okay, now this one station information, station, name of station. Now we need X and Y. Okay, that's mean latitude and longitude. Insert right, click it OK. So lat, that's mean latitude and longitude. Okay, so here station information, you have to copy this one from the station information and paste here. Okay, first station, this one, Kupwara, Gulmarg, might be from Jammu Kashmir. Okay, very good place. Now Srinagar. Okay, Palagram, Ctrl V, Kajigund, Ctrl V, and Kokonak. Okay, now open a fresh Excel, a new Excel, just take a copy and paste here, and now go to file, save as, you can save anywhere. Now I will save it in my D drive, personal D drive, and here the Ishak climate data. save it. Okay, now we have to do one thing. We have to save it in earlier version of Excel. Sometime ArcGIS cannot detect the advanced version, so we have to save it in earlier version of Excel. So for this purpose, now just see this one, save as X types. So now here you can save it Excel 97 2003. Okay, if you save it in Excel 97 2003, then you never will face problem when you're adding in ArcGIS 97 2003 format. Save it. Okay. Now close it. You must close this one, your Excel file. Now again open a new work map. Now add here your geographic projected data, not projected data. Your data should be in geographic projected, that's mean in WGS. So boundary shape, add it here. Now go to properties. Now see this one, this is in WGS 1984. So now go to file here and add data. Now add XY data. Okay, and click it browse button here. This one climate data, not date, data 97 2003. Add it, and now click sheet 1, add it. Now see, this is in geographic coordinate system. Click it OK and OK. Now see, it is false correctly inside this boundary, but this is in temporary data. We should export this data. So now right click, go to data and export data. This is a common function in ArcGIS. So now export it. Click it, export D Ishak. Now climate. Now save it. Click it OK. Okay. Now one thing here, this is now geographic projected system. Now you can convert in projected coordinate system. No need this one, this file you can remove now. So right click, go to data frame. I don't know the UTM zone. So you can select UTM zone from here, add data. Now go to your C drive. Then you can find here ArcGIS folder, ArcGIS desktop version here. In C drive, then program files 86, then ArcGIS, then ArcGIS desktop, then reference system, UTM show. Now you can add here UTM zone, just add it. Okay, so this is UTM. Right click, again go to properties. Now see here this level, select this level. Okay, select level features in this layer. Now change this level field to zone, this one. Just change this color for visualization, for better visualization. Change it red and click it OK. Now see this one, 43 zone. Okay, you can find your UTM zone this way. So now right click in this area, anywhere, go to data frame properties, and this one projected coordinate system. Okay, then go to UTM, then go to WGS 1984, then northern hemisphere, then 43. You have to select 43 UTM zone, this one, WGS 1984 UTM zone 43. You can add it in your favorite like this way. Add to your favorite, this button here. Okay, apply and OK. Now this one climate data, again go to data and export data. Now we have to select this data frame. Now data frame has changed to UTM. So now climate data, this one in UTM. UTM and save it and click it OK. Yes, I want to export it, so no need this one, known as this geographic projection system. You can add now your projected coordinate system. So now download. Ishak sent me his data name as, I think, G-data climate, this one boundary. Yes, add it. So this is projected data now. Okay, go to source. Yeah, this one projected data. So now go to your Arc toolbox for interpolation. In ArcMap you can find many technique for interpolation technique, like in spatial analysis tool. Here, click it here, then see this one, interpolation. You can find here IDW, clicking, natural neighbors, spline with barrier, topo to raster by file. Then we have to understand every technique, why you use IDW or why you use jigging technique. Definitely I'll be live and another day I'll define what are the difference between those techniques. But we have to understand what is IDW. We all know IDW means inverse distance weighted. So IDW tools uses a method of interpolation, estimated cell values. Just estimate the cell values by averaging the values of same sample data points in the neighborhood of each processing cell. So we have 6 sample point, and using this 6 sample point, IDW will convert a neighborhood method, and the closer a point is to be center of the cell being estimated, and also the more influence or weight it has in the averaging process. So if you click IDW, double click here, then it will be open. Now in this window you can find many options. One, input point features, definitely climate data now or input. And now Z value mean here field. Okay, so our field will be maybe Tmax, Tmin and precipitation. So first time I will do for Tmax. And output raster, it will be convert into raster data. So we should use our personal geodatabase or file geodatabase or TIF format. So just change this output part. Okay, Ishak, this one for Tmax. Your output will be TIF. This is you must give TIF format when using raster data. Now see, output cell size, it's optional, but sometimes we have to change it. Okay, now go to environment. Now processing extent, this one processing extent, and default we should change to same as boundary, and also we have to change raster analysis, mask as boundary, and click it OK. Now see, cell size 592. You can change it to 30 meter also. Sometimes we need change to validate our model to for multi-criteria decision making model. Okay, so the output value for a cell using inverse distance weighting is limited to the range of value used to interpolate. So it will be limited to the range from, in this case Tmax range maybe 30 to 25. So output value range is within this range, and because of IDW is a weighted distance average method, so the average cannot be greater than the highest value or it cannot be less than the lowest input. So therefore it cannot reach a value if this extreme have not already been sampled. So now just click on OK button. Okay, just change it, this one, make it hollow. This one Tmax. Okay, again Arc Toolbox, IDW, then climate UTM. This time for minimum temperature, change it to Tmin, save it and go to environment. Now processing extent, it should be according to our boundary, and also raster analysis, it should be mask according to our boundary, and click it OK, and change to output cell to 30 meter. That's why I have changed it to UTM zone. Just click it OK. It will take time. This time we use kriging technique. Kriging technique takes more time than IDW. IDW takes minimum time. But generally kriging takes maximum time. So we should wait. And another thing, suppose in this case, remove it, add here data, D, then Ishak, that climate UTM, okay, make it hollow. So Arc Toolbox, then go to Special Analysis tool, this one. Now Interpolation technique, click on IDW. Now input features, your climate UTM, latitude, precipitation, and output raster, it should be precipitation. Precipitation. Okay, now we have to change our processing extent, default to boundary, and also raster analysis, mask as boundary. Click it OK, and change output cell size as a customized cell size 30, 15, 10. It's depend on your objective, it depend on your purpose. Now this is precipitation. Now see, clicking now working. Okay, it will take maximum time. Okay, still is working. So again go to Arc Toolbox, click IDW, climate UTM, Tmax, output, Tmax IDW, and save it. Environment, processing extent, default as boundary, and then raster analysis, mask as boundary. Then click it OK, and change this output cell size to 30 meter, and click it OK. Okay, now see, it will take very less time. It's now working. So take a copy this one, I'll process here. Now click on layer and paste layer. So Tmax, this one Tmax, and also this one Tmax. We have to calculate Tmin. Okay, no issue, you can calculate this way. Now final stacks, this is Tmax, okay, and this one Let's remove this one, precipitation, again add here Tmax IDW, yes, some raster data. So now see, since it is raster data, so it is in stress. Just double click here and go to symbology, then you can classify it according to various classified rule. Suppose here one of technique, natural break, manual, equal interval, defined interval, quantile, natural break, geometrical interval, standard deviation. Definitely I will make another tutorial about this classification method. So today I will go with natural break method, but you can change it to manual. Just click it OK and go to level, format level. You can format level to 2 decimal like this way, 2 decimal, and click it OK. Change this color. This is for maximum temperature, so I can use color, suppose this color. Okay, you can choose. Okay, just flip this color, then it will be inverse. So now go to climate, go to properties, and here the level, this one. Now select this level and change here station, this one, 14, apply and OK. Now see this one, it shows the station name here. Okay, so viewers, today up to here. If you have any question, you can ask in this comment section. No comment. Okay, so I'll stop here. If you have any query, Monitapu, okay, Ranjit, if you have any question regarding this, then I'll share my view. No comment? No. So then, oh, Isfaq Guzre, are you here? Okay, it is for you. I'll mail you all this output. Okay, hope you enjoy this tutorial. I will come online. I'll try to come online regularly on Sunday.